Hello, everyone. In this video, we're going to be going through a deep dive of all of the methods in Java's string class. But before we get started, let's do a quick summary of what a string is, because I think that's important to understand these methods. The string class represents character strings. So all string literals in Java programs, such as the example they give here, ABC, are implemented as instances of this class. So strings are constant and their values cannot be changed after they are created. String buffers support mutable strings, which I will cover in another video. Because string objects are immutable, they can be shared. So for example, here we have a string, which is our keyword. Notice the capital letter. For this one is called str, and we're defining it as ABC. So it's important to remember that this is equivalent to an array of characters. So A, B, C. So the first method we're going to get into is the length method. So the length method returns the length of the string. The length is equal to the number of the Unicode code units in the string. In other words, how many characters makes up the string as a whole. And it's going to return an int, a discrete number of how many characters there are. Okay, let's go in our IDE here, IntelliJ, to look at an example here. So as you can see here, we are defining a string to be hello world, and we're printing out the length of the string. Because remember, string.length, that is going to be an integer. So let's run it. As you can see here, it prints out the length of the string, which is 13 characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 characters. Okay, so next, let's move on to isEmpty. So isEmpty returns true if and only if the length is 0. So this is an application of the length method. And obviously it returns a Boolean. So let's take a look at an example in IntelliJ. So for this example, we're defining a string that is empty and a string that says just hello. And we're going to print out whether string 1 is empty and whether string 2 is empty. Okay, let's run this program. As you can see here, string 1 is empty. Is string 1 empty? That's true because there's no characters in it. And is string 2 empty? That's false because there are characters in it. Okay, let's move on to our next example here. charAt or charAt. So this returns the char value at the specified index. Remember, in programming, we start counting from 0 to length minus 1. Okay? The first character value of the sequence is at index 0, the next is at index 1, and so on until we get to length minus 1. And as you can imagine, it returns a char. And we're passing in the index. Okay, let's take a look at our example here. So for this example, we have a string text and it's defined as Java. And we are defining a character that is at the index 1 of text. So we would expect that to be A, because again, we start counting at 0. Index 0 is capital J, index 1 is A, index 2 is V, and index 3 is A. So let's run this example program. As you can see, it produces the expected output of lowercase a. Okay, let's move on to our next example. We're going to cover codePointAt, codePointBefore, and codePointCount because they are related all at once here. So all three, well, the first two, codePointAt and codePointBefore, take in an index. CodePointAt returns a character, in other words, the Unicode code point at the specified index. And again, as it was in charAt, it ranges from 0 to length -1. And we're returning an int because that's the Unicode code. CodePointBefore, again, we're also passing in the index, but we're returning the character before the specified index. So the index refers to the character values and ranges from 1 to length. And again, we're returning an int. Lastly, in codePointCount, we are passing in a beginning index and an ending index. And we return the number of Unicode code points in the specified text range of the string. Okay, so let's go in our code example. So for codePointAt, as you can see, we're defining a string of text that says hello. Then we're getting the Unicode code point at index 1, and then we're printing that out. So let's run it. As you can see, this is the code point for the character we are looking at. So going into codePointBefore, again, we're defining a string of text as hello, and we're asking for the Unicode code point before index 2. So again, that's going to produce the same result because we're asking for the one before 2, which is 1. And then finally, codePointCount, we're asking, for this example, we're using the same hello string, and we're counting the Unicode code points from 0 to 3 exclusive. So let's run that. As you can see, there are 3 Unicode code points. All right, let us continue on to offset by code points. This returns the index within the string that is offset from the given index by code point offset code points. And as you can see, we're passing in the index and we're passing in the offset. And it's returning an int. So let's go into our program. As you can see here, we have a string with an emoticon or emoji or however you want to refer to it. And we're going to define here int new index. That's going to be the method. We're passing in 6 and 2 for the index and code point offset respectively. And then we're going to print that out. So let's run it. As you can see here, the new index after the offset is 9. All right, let's continue on to our next method, which is getChars. So getChars has 4 inputs, and it copies characters from the string into the destination character array. So the first character to be copied is at index source begin, which is our first parameter. The last character to be copied is at index source end -1, which the source end is our second argument or parameter. The characters are copied into the subarray of destination, starting at index, destination begin, and ending at index, which destination and destination begin are 2 other parameters, and it returns void because we're just getting the chars and we're copying the characters from a string into the destination. Okay, let us test this out. So we are defining a string source, hello world. We're coming up with a destination with room for 20 characters, a char array with a room of 20 characters. We are performing the getChars method from 7 to 12 and putting into index at index 5. And then we're going to print those out. So let's run. As you can see here, destination array after getChars operation. Okay. Let us move on to our next method, getBytes. So it's probably better to start down here. So getBytes has four overloaded methods. So the first type returns a byte. Well, you'll see they all return an array of bytes. But starting off with our no parameter one, this encodes the string into a sequence of bytes using the default char set, and that's storing the result into a new byte array. The first overload method passes in a char set, so it performs the exact same thing, encodes the string into a sequence of bytes using the given char set, and then the second one, the third one encodes the string into a sequence of bytes using the named char set in the string. Regardless, they all go into a byte array. And then this getBytes is depreciated, so do not worry about that. So let us go into the code now. Go and getBytes. So as you can see here, we have the hello string. We are using the default char set by not passing anything into the method. And then we are encoding using a specific char set with this method. Well, with this method calling. And then we are encoding within using a string name. So let's run this. Regardless, they all say hello. Okay, let's move on to our next method here, which is equals. So this compares the string to the specified object. The result is true if and only if the argument is not null and is a string object that represents the same sequence of characters as this object. So in other words, they're the same string, same words. Okay, and let's take a look at that in the code. So we have a couple examples here. We're finding string 1 and string 2 as hello, and for string 3 we're declaring a new string object. So let's run it. So it says string 1 is equal to string 2, as it is. String 1 is equal to string 3, which it is. And string 1 is not equal to string 4, because this is a case sensitive comparison. Okay, let us move on to our next method, content equals. So content equals has two different overload methods and two different parameters. You can either pass in a string buffer, which will again be covered in another video, and a char sequence, which will be covered in another video. In other words, where the string is being compared to either the string buffer or the char sequence using the same logic as our previous equals method, right? So all the characters are the same. Okay, let's take a look at an example. And then, so as you can see here, we have a string text, a char sequence, and a string buffer that all says hello. As you can see here, our first Boolean is checking to see if the text is equal to the sequence, and then our second Boolean is checking to see if the text is equal to the buffer. So let's run that, and they both return true. Okay, so our next method we're going to get into is equals ignore case. So this is very similar to equals. However, case considerations are ignored. So let's take a look at an example. At equals ignore case. So we have string 1 says hello. String 2 says hello but is not capitalized. String 3 says all caps hello, and then string 4 is world, so different string. So our first comparison is to see if string 1 is equal to string 2, and we would say yes it is, ignoring case. Then our second if else is seeing if string 1 is equal to string 3, which again it is, ignoring case. And then the last one is checking to see if string 1 is equal to string 4, ignoring case, and it is not. They're different words. Okay, so let us run this. And as we can see, string 1 is equal to string 2 and 3, but not equal to string 4. Again, ignoring case. All right, let's move on to our next method, compareTo. So this is a little different. This method compares two strings lexicographically. So the comparison is based on the Unicode value of each character in the string. Character sequence is represented by the string object. That is compared lexicographically to the character sequence represented by the argument. The result is negative integer if the string object lexicographically precedes the argument string. And then the result is a positive integer if the string object lexicographically follows the argument string. And finally, the third case is they're equal, and in that case, the result is 0. So let's take a look. Let's take a look at this. As you can see, we have two strings, apple, banana, and we're comparing them, and then we're producing the result. So as you can see, it outputs -1 because apple lexicographically precedes banana. But if we switch these around, it's positive because banana lexicographically succeeds apple. Okay, let's move on to our next method here. compareTo ignore case. So this is very similar to the last one, but they are ignoring case differences. Okay, let's take a look at an example. As you can see, we have both apple and apple, but the first apple is capitalized and the second one is not. And we're calling the same method here. We're comparing text 1 to text 2, but we're ignoring case. So as you see, it's 0 because ignoring case, they are lexicographically equal. Okay, let's move on to our next method, regionMatches. So we have two different overload methods here. The first one takes in a t offset, an other string, an o offset, and a length. So This tests to see if two string regions are equal. And then getting in specifically with our parameters, T offset is the starting offset of the subregion in the string. Other is the string argument. O offset is the starting offset of the subregion in the string argument. And the length, or len, is the number of characters to compare. Okay, let us, and also returns true if exactly matches and then false otherwise. Region matches. You can also, at the beginning, the first parameter you can specify ignore case. So same method with regular and ignore case. So let's look at an example here. So we have hello world and hello world, which with the latter being all caps. So when we run this, the case sensitive match produces a false reading. And then the case insensitive match produces a result of true because they are the same letters but not the same capitalization. Okay, let's move on to our next example, or next method, rather, starts with. So starts with tests to see if the substring of the string beginning at the specified index starts with the specified prefix. So that's the first overload method of starts with, and then second one just tests to see if the string starts with a specified prefix, and then true if the character sequence represented um, by the string is a prefix, and then false otherwise. Same thing for both. All right, let us take a look at an example. As you can see here, our first example looks at hello world and just sees if it starts with hello, which it does. And then our second example uh, sees if it starts with world at offset 7. And then we're going to print out both results. So let's run this. As you can see, they're both true. All right, our next method is going to be ends with. So this tests to see if the string ends with the specified suffix, and it returns true if it does, and then false otherwise. All right, let us take a look at an example. As you can see here, for this example, we're using text, different file extensions. So first we're gonna see if file name 1 is a text file, which it is because we're reading .text. Second one, we're seeing if file name 2 is a text file, which it's not because it has a .png extension. And then lastly, we're going to see if file name 3 and is a PDF document, which it is, since it has the same suffix. So let's run it. And as you can see, our assumptions are correct. Okay, let us move on now to our next method, hashCode. So hashCode, there's no arguments here. It just returns a hashCode for the string. And the hashCode for a string object is computed, as you can see in this equation here, using int arithmetic, where s within the I index is the ith character of the string, n is the length of the string, and then the caret obviously indicates exponent. The hash value of the empty string is 0, but regardless, it returns as an int. So let's take a look at an example. As you can see, we have 4 strings here. So we have First one is hello, second one's the same thing, third one is world, and then the fourth one is defining a new string being hello. Then we're going to get the hash codes, then we're going to display the hash codes, and then we're going to check to see if they're the same for identical content. So let's run. As you can see here, the hash code of string 1 and 2 are the same, as well as 4, because they are just hello. But the hash code of string 3 is different. String 1 and string 2 have the same hash code. String 1 and string 4 have the same, but string 1 and string 3 have different ones. Okay, so our next example is going to be indexOf. This has a lot of overload methods. So the first one returns an index within the string of the first occurrence of the specified character. The second one returns index within the string of the first occurrence of the specified character, starting at the search of the specified index, which is the additional parameter. The third one returns index within the string of the first occurrence of the specified character, starting at begin index and stopping before end index. Next, again, very similar, but here we're defining, we're passing in a string, which is the substring to search for. And then the next one is we're searching for the substring from starting at a particular index. And then the last one is searching for a substring from the beginning and end to the beginning and end. Okay, let's take a look at an example here. As you can see, we have, no, we're combining with lastIndexOf, and I'll cover that in a second. But the first one is we're looking for the first occurrence of the lowercase o. The second one, we're looking for lowercase o after index 5. So it's not going to be the o and hello in the first hello. Third one, fifth one is we're finding the first occurrence of hello, the string hello. And then the sixth one, we're looking for the substring hello after index 10. And that's all we'll do for that example. Let me go into lastIndexOf next. So lastIndexOf, we're looking for the first one, we're looking for a particular character. The second one, we're looking for the particular character starting at a particular index. And then the next one is we're looking for a substring, the last occurrence of that substring. And then finally, we're looking for a substring starting at a particular index. So let's take a look at those examples in that same program. As you can see here, we're looking for the last occurrence of O. Next one, we're looking for we're looking for the last occurrence of O before index 15, for example, here. And then finally, for these two ones, we're looking for the last occurrence of hello, and then the last occurrence of hello before index 10. So let us run this whole program. And if it helps, feel free to comment, well, not comment, but pause the video to take a look at these results and compare to what you're thinking. Okay, let's move on to our next method here. Substring. So substring has two overloaded methods. Regardless, they return a string that is a substring of the string. The substring begins with a character at the specified index and extends to the end of the string. So with this one, we're just specifying a beginning index. And in this overload method, we are defining an end index as well. And you can take a look at these two examples here. All right, let us take a look at an example. So we're defining a string here saying hello world. We're for the first one, we're defining a beginning index, and then in the second one, we are defining a range. So as you can see here, we're going to run. And as you can see, the first substring is world, and then the second substring is hello. Okay, let us move on to our next method, subsequence. So subsequence returns a character sequence that is a subsequence of the sequence. So again, we're defining a beginning index and an end index. So let's take a look at that in an example. So as you can see here, we are extracting a subsequence from index 7 to 12. And then we're displaying our original and our subsequence. So let's run this. As you can see here, the original string is displayed and then our subsequence. All right, let's move on to our next method, concat. Essentially, this adds. You could also think of it as appending the specified string to the end of. So the specified string as an argument and to the end of the string that is calling the method itself. So again, the string being passed in, just to make sure this makes sense, is the string that is being appended to the end of the string. So let's take a look at that in an example. So we're gonna basically merge these two together to form hello world. So as you can see, we're adding appending world, note the space as well, to the end of text 1. Okay, let us move on to our next method, replace. So we are returning a string that is resulting from replacing all occurrences of an old character in the string with a new character. And then those happen to be the two parameters. So old char is the old character and new char is the new character. And it's returning a string specifically. So let us take a look at that. For our first example here, we are replacing a lowercase a with a capital A. And then we are replacing our apple with orange. So I'll show you that under the second overload method here, which you could just consider it a string at that point, right? So the target is what we're replacing, and then the replacement is the replacement sequence. So moving on to replace first, we are passing in a regex and a replacement. So we're replacing the first substring of the string that matches the given regular expression with the given replacement. So looking at our example, we are replacing only the first occurrence of A with an at sign. And then taking a look at replace all, we're replacing each substring of the string that matches the given regular expression with the same arguments. So as you can see here, we're replacing all occurrences of A using the regex. So let us run this. As you can see here, this shows 4 successful operations. First one replaces all instances of lowercase a. Second example replaces all replaces the word apple with orange. The third example replaces all lowercase a's with the at sign, and then example 4 replaces only the first one. So let us, well, we already ran it, so hopefully that makes sense. And now let's move on to our next method, matches. So we're telling whether the string matches the given regular expression. So let's take a look at that. So as you can see here, we're specifying a string, and we're going to see if it's numeric. In other words, does it only contain digits? As you can see here, that's true. But if we add on an A, turns out to be false. Okay, let's move on to another method. Contains. So this is quite simple. It returns true if and only if the string contains a specified sequence of char values. And then S is the sequence to search for. So let's take a look in contains. So we're going to see if both these texts contain Java or not. So let us run it. As you can see here, Java programming obviously includes Java, but Python programming does not. All right, let's move on to our next method, which is split. So split splits the string around matches of the given regular expression. And those happen to be the two things we're passing in. So the array returned by this method contains each substring of the string that is terminated by another substring that matches the given expression or is terminated by the end of the string. So let's take a look at an example. So our text here, we're going to first split as a comma. Then our second one, we're going to split with a comma and limit to 2. Third one, we're going to split using A. And then our fourth one is we're going to split with a non-matching regex. So that's run this. And as you can see, these results make sense. So first, we're splitting with a comma and having 4 distinct. Next one, we're limiting to 2. So as we can see here, we have apple, and then we have a full string here. And then next one, we're splitting using A as a delimiter. And then the fourth one is we're splitting with Z, which is a non-matching regex. So as you can see, nothing changed. All right, let's move on to our next method. Split with delimiters. So this is quite similar. It splits the string around matches of the given regular expression and returns both the strings and the matching delimiters. And we're passing in a regex and a limit. So let's take a look at an example here. So you can see we're defining a text. We're splitting with delimiters and limiting to 5. And then demonstration of the method. And then we're going to print out the result. So let's run this. As you can see, this prints out the expected output. All right, let's move on to our next example, join. So join returns a new string composed of copies of the char sequence elements joined together. And then we're passing in a delimiter and then the elements. So, well, and then also for this one, um, for this second overload method, we're also passing in the delimiter, but we're also passing in an iterable that will have its elements joined together. So let's take a look at that. As you can see, we have two different operations happening, but let's run it. As we can see here, apple, banana, cherry are going to be joined together with a comma. With the second example here, we're passing in a words, which is, as you can see, and it is an iterable, but our delimiter is the bar, and that makes sense. So let us move on to our next example, to lowercase. Simply put, this converts all the characters in the string to lowercase. And we're either not passing in a locale or are. So let us take a look in a program here. As you can see, we're either, for the first one, we're not passing in a locale, and the second one we are. So running that gets us the expected result. Okay, moving on to our next example here. toUpperCase. Again, very similar, but we're converting it to uppercase now. Either passing in a locale or not. So let's take a look at that one. Similarly put, we either are not passing a locale and we are. So that checks out. So our next method here is trim. So trim returns a string whose value is the string with all leading and trailing space removed. And we're not passing anything because it's just the string. So let's take a look at that. We're using the close brackets as an example here. So originally, there's the leading and trailing space, but trimmed, there's not. Okay, let's move on to our next example, or next method, strip. And we're going to talk about here. We're going to talk about strip leading, and strip trailing all at once because they're very similar. So strip returns a string whose value is the string with all leading and trailing white space removed. Very similar to trim. Strip leading returns a string whose value is the string with all leading white space removed only. And then trailing is quite similar, but with all trailing white space removed. Again, no parameters passed in any of these. So let us take a look. We have all four options here. Original, just strip, strip leading, and strip trailing. All right, so our next example here is going to be blank. So quite simply, this returns true if the string is empty or contains only white space, code points. Otherwise, it's false. So let's take a look at that. As you can see here, we have an empty string, a white space string, and a non-empty string. The first two return true, and then the third one returns false. Okay, so for our next one, we're going to be doing lines. This returns a stream of lines extracted from the string, separated by line terminators. So let's take a look at this one in an example. So we have, as you can see, we literally have new line here. And as you can see, it actually split into three strings. Okay, next, let's move on to indent. So indent adjusts the indentation of each line of the string on the value of n, and then normalizes the line termination characters. And we're only passing in n, which is the number of leading white space characters to add or remove. So let's take a look at that. We have an original and one that is indented. So that checks out. Okay, our next example is strip indent. So this does the opposite. It takes away the indent. In practice, I've struggled to get this to work with something like this with menu lines, but I have a multiple line example with hello with lost space before it. So we have our original and stripped printed out. And as you can see, that checks out. Okay, our next one is going to be translate escapes. So translate escapes returns a value whose value is a string with escape sequences translated as if in a string literal. So all of them are translated here, but I'm going to show you an example. In translate escapes. So as you can see here, we're containing a literal new line. So let's print out the original and the translated one. And that checks out. So the next method we're going to do is transform. So this method allows the application of a function to the string. And then we're passing in a function to apply. So let's take a look. Transform. So here we're calling reverse and toUpperCase. So as you can see here, the original string is printed, then after the transform function is called, and then after the reverse function is called. So let's move on to our next example. ToString. This quite simply um, returns the string itself. So let's take a look. And this is quite simple. Yeah, this is quite simple and more useful for other. The ToString is more useful for other things. So you won't see this used much. But moving on to chars, this returns a stream of int 0 extending the char values from the sequence. Okay, let's pass in. Take a look at an example. Which again, it returns a stream of int 0 extending the char values. So the next one we're going to talk about is code points. So code points returns a stream of code point values from the sequence. And the next one we're going to talk about is toCharArray. So this converts a string to a new character array. So let's take a look at that one. As you can see, we're calling the method, and we're splitting up hello into its characters. Okay, so next, let's get into format. Okay, so format, we have two overload methods here. We're returning a formatted string using the specified format string and arguments, and optionally the specified locale. So let's take a look at that. As you can see here, we have the default locale and we have a French locale for these two different strings. Okay, next, let's get into formatted. So formatted formats using the string as the format string and the supplied arguments. So it just returns a formatted string. So let's take a look at that. As you can see here, we're just passing in arguments to the template. Okay. So next, let's get into valueOf. So we have a lot of different options here. So essentially, we're returning the string representation of either an object, a char array, a char array with an offset and count, a boolean, a character itself, an int, a long, a float, or a double. So let's take a look at an example of that. This one isn't exhaustive, but it should show the point. We're using the value of an int, a double, and a boolean. So as you can see here, it um, turns into a string basically. So okay, next we're gonna get into intern. Intern. No, I'm sorry. Copy valueOf. We almost missed that one. So copy valueOf takes in a char array of data with an offset and count, or optionally just a char array. Okay, let's take a look at an example of that though. So we're creating a string from the entire character array, and here we're creating a string from a subarray. So as you can see, were both successful. Okay. Next, let's get into intern. So intern returns a canonical representation for the string object. So let's take a look at an example of that. As you can see here, we have hello as a new, using new operator and just by itself. As you can see, both references point to the same object in the string pool. So next, let's get into repeat. So this returns a string whose value is the addition or appended string repeated 4 times. So let's take a look at that. As you can see here, we're calling it 3 times. As you can see here, hello, hello, hello. Next, let's again to describe constable. This returns an optional containing the nominal descriptor for the instance, which is instance itself. So let's take a look at that. As you can see here, the output is going to be optional and then hello Java 12 in the brackets. Okay, next is the resolve constant descriptor. This resolves the instance as a constant descriptor on the result, which is the instance itself. So let's take a look at that. As you can see here, it just outputs the same thing. So I hope that this video was useful. Again, note that obviously I referred to the Java docs about string for this video. So obviously take a look at that. And this will give even more information than I provided. But I hope this video was informative. I appreciate your time watching. Let me know if you have any questions and have a great day.